In the last video, we saw how you can think about the continuation condition for while loops by testing values and thinking about what will happen, also by using De Morgan's law to translate the continue condition into the stopping condition. So in this video, let's look at a couple of kind of semi-real life programming scenarios where you might have to put those skills to work. So in each of the three problems, there's a desired behavior, there's an attempt at a solution, and you have to decide, does this actually work? Does it not work? If it doesn't work, how could you make it work? Okay, so here, if I look on the inside of the loop, it looks like I'm flipping a coin, and I'm either adding to a counter for how many heads did I get, or a counter for how many tails did I get. And it says that I want to keep doing this. I want to keep flipping the coin until I get at least 3 heads and at least 3 tails. Okay, so let's try the two skills. Let's try and imagine. Here, let's do this on the right-hand side. Let's try and imagine a condition where it should stop and a condition where it should keep going. So let's see. I want to keep going as long as I want to keep going until I get a big enough number of heads and tails. Okay, so let's say if heads is 4 and tails is 4, then I should stop because I got enough of each. Okay, so now let's also think about if heads is 2 and tails is 4. In that case, I shouldn't stop. Let's say don't stop. I shouldn't stop because I don't have enough heads and I want to keep going. Okay, so let's actually test the condition now and see if it works. Okay, sorry for this bad penmanship. So if heads is 2 and tails is 4, let's plug those values in and see what happens. So here I'm just using H and T because it's shorter to write. Okay, so if heads is 2, and I plug it in here, it is true that 2 is smaller than 3. So that becomes true. Here, if tails is 4, it's false that 4 is smaller than 3. So now I combine these. I think, okay, true and false. So in order for the entire conjunction to be true, both of these would have to be true. So true and false evaluates to be false. But I've still got this not symbol on the outside, so not false becomes true. And remember, a true inside a while loop means that we are going to loop one more time. Did that do what we wanted? In this situation, we didn't want to stop, and in fact, it's going to loop one more time. So this seems to have worked. Okay, but it's really important that you test both cases that you want to happen. You know, sometimes we want it to stop. So let's look at this. If heads is 4, then that means this is false because 4 is not smaller than 3. This is also false. False and false is false. And remember, we've got the not in front. And so this is turning out just the same as the other case. Not false becomes true. So that means that we are not going to stop, but we should have stopped in this case. So this is an example of it failing to work. In this situation, it should have stopped, but it's not going to. Okay, over on this side, let's actually translate this into the stopping condition to see why. Okay, so I just wrote the continuation condition. If we're not continuing, we're stopping. So my stop condition would be not the continuation condition. If it's not true that something's not true, that means it's true. The nots are going to eliminate each other. So the simplified stopping condition would be heads is less than 3 and tails is less than 3. So this seems like, if I think logically, this seems exactly backwards. I want to keep looping until I get at least enough heads and tails, but it's going to stop if heads and tails are both less than the target amount I'm trying to get to. So if we'd actually tested the initial conditions, heads is 0, tails is 0, let's see, heads is 0 would make this true, tails is 0 would make that true, true and true is true, not true would be false, and so we'd exit right away. So actually this loop is just going to exit right away. All right, so how can we rewrite it to do what we want? Let's start with the stopping condition that we wish we had. So I'm going to think about the stopping condition I want. I want to stop when we have enough heads and enough tails. So I want to stop when heads is greater than or equal to 3, and also tails is greater than or equal to 3. Okay, so now let's translate that into a condition that would work in my while loop. So the continuation condition in my while loop is going to be when it's not true that I'm stopping. So if it's not the case that I'm stopping, I want to continue. So not h bigger than or equal to 3 and tails bigger than or equal to 3. We could just write that. Let's go ahead and use De Morgan's law to translate it, though. So we're going to continue as long as, let's see, if it's not true that h is bigger than or equal to 3, it must be that h is less than 3. And then an or, because De Morgan, and then less than 3. So we want to continue as long as either heads is too small or tails is too small. So this is what we would actually want to put inside the while condition here, something that looks like this. Okay, if this was revelatory for you, you are figuring stuff out that you didn't know how to think about before, don't watch the rest of the video, stop and go back and try some more problems. Otherwise, let's go on to the next one. Okay, so in this problem, I have a cart object. There's a checkout method, which appears to return a cart object with some information about the cart that they're trying to check out. And we can ask the cart how many items are there, and we can ask the cart, like, what's the overall weight of all the items. And here it says, if the user is attempting to check out, but their cart is too heavy, or their item count is too big, make them check out again until both are acceptable. So this actually isn't giving me a stopping condition. This is telling me what is true if we're going to make them do it over again. What's the continuation condition? So this problem, we can almost just try and write the continuation condition directly. Or I guess let's read it and see if this works. So this says keep going, like do it again, if the item count is small enough and the weight is small enough. But logically, if the item count is okay and the weight is okay, we should allow them to, do the checkout they're trying to do. There's no sense in going back and making them do it again. So again, this feels like a little bit backwards. I feel like the continuation condition we want to say is do it again if... So if the item count is too big, we would want to make them go back and do it again. Or if the cart weight was too big. If either one of those is true, we would want to go back and do it again, and that's exactly the situation when the or symbol is appropriate. Okay. Oh, incidentally, my English language description was ambiguous about whether it's okay or not if the item count is exactly equal to max items, so I don't care either way if you mark greater than or equal to, because the specification didn't say. Although, if this was real programming, you would probably want to check in with yourself or with whoever was telling you to be precise about this edge condition. Okay, let's do the last one. So here, someone's going to attempt a password, and if something goes wrong with the password, we're going to kind of make them do it again. So it says keep asking them for a password until either they get the password right, and that seems what this Boolean correct is about, did they get it right, or if they have more than 2 incorrect attempts. So if they do a password attempt, it's wrong, we add to the attempt counter. That's okay, they got one wrong, we'll try it again. If they try it a third time and they still get it wrong, that's when we want to exit the loop. So we'll either exit the loop when they get it right, or we'll exit the loop if we've looped 3 times and we haven't exited yet because they got it correct. Okay, so here again, it seems like we are being given a stopping condition. We want to stop it when they get it right, or we want to stop it when they have more than 2 incorrect attempts. So let's write the stopping condition and try and translate it to the continuation condition. Okay, so we want to stop if they get it correct. Just as a side note, some people are still writing if correct equals true, which is fine. There's nothing wrong with that exactly, but it's not necessary because correct is already true or false. So if comparing correct to true is going to evaluate to be true, it has to be when correct is already true by itself. And so that makes the comparison unnecessary. You would just check if true. Okay, so we would stop either if they got it correct already, or if their attempts are too many, or if attempts, let's see, if they have more than 2 incorrect attempts, so greater than 2 or greater than or equal to 3. Okay, and I used an or symbol here because if they got it correct, but this one's false, that's okay. Like, let's say it's their 3rd attempt and they got it correct. That's all right. We want to stop. If they didn't get it correct, but they have too many attempts, we also want to stop. So if either one of those two is happening, we want to stop. Okay, so now let's translate that into the continue condition. We want to continue if it's not true that we're stopping. So if it's not true that we got it correct, or attempts is bigger than or equal to 3. So again, let's use De Morgan, and we'll say we'll continue if it's not correct and we haven't exhausted our attempts yet. So attempts is less than 3. And now let's see what that looks like up here. So here, the not correct is the same, attempts less than 3 is the same, but the or should be an and that's what's causing the code not to work. So I hope that this was helpful. This is a really, really commonly occurring situation when you're programming, is to have multiple conditions, and you got to check to see if a while loop makes sense. So I hope that this will actually be helpful in your real programming.